So what in the world could a beehive, the stock market, and your smartphone possibly have in common? I mean, they seem like they're from completely different worlds, right? But believe it or not, they all run on the exact same hidden principle. And today, we're going to unlock that principle by breaking down one simple, powerful idea: the system.
Okay, so let's start with a bit of a puzzle. A huge forest, the computer sitting on your desk, and the entire internet. What's the common thread? It feels like a totally random list, I know, but they all share a secret identity. See, at their very core, every single one of them is a system. So let's peel back the layers and see what that actually means.
All right, here's our game plan. First, we're going to nail down what a system even is. Then we'll look at the two big categories: natural and man-made. After that, we're going to dive deep into the computer as our main case study and build our way all the way up to the internet itself.
So, let's get right to it. What is a system? It's a word we throw around all the time, right? But in science and technology, it has a really specific meaning. It's not just a bunch of stuff. It's about how all that stuff is connected and works together.
Here's the textbook definition, but let's make it simple. A system is a bunch of interconnected parts, and that's the key. They have to be linked, that are all working together to hit some kind of common goal. And this whole operation happens inside a specific environment. You know, think of it like a sports team. You've got the players, those are the parts. You've got the goal of winning the game, that's the objective. And they're all playing on a field, that's the environment.
Yeah, the secret sauce here is really the interaction between the parts. I mean, think about a car engine. You can have all the pieces, pistons, spark plugs, a gas tank just sitting on the floor. But if they aren't connected just right and communicating in a super precise way, you don't have an engine. You've just got a pile of expensive metal. It's that connection, that communication, that turns a pile of parts into a working system.
Okay, so once you know what to look for, you start seeing systems absolutely everywhere. But they pretty much fall into two big families: the ones that just pop up in nature, and the ones that we humans actually design and build.
The big difference here really boils down to intent. Natural systems like a rainforest or your own body, they just emerge organically. Their objective wasn't designed by anyone. It's all about balance, survival, keeping things going. But artificial systems, well, we build those with a very specific goal in mind. A car is built to solve the problem of getting from A to B. A company is organized to make and sell a product. There are deliberate solutions to specific problems.
And this brings us to our main event, the computer. Honestly, it's probably one of the most complex and one of the most perfect examples of an artificial, man-made system that we have today.
Just think about it for a second. Using that definition we just learned, a computer has a really clear goal: process information. It's made of obvious distinct parts, right? A screen, a keyboard, a processor. And it's totally connected to its surroundings. It needs electricity from the wall, it connects to the internet, and it interacts with you. It checks every single box. And this isn't just us trying to make a cool analogy. This is a core fundamental principle of computer science. The foundational texts that shaped the entire field defined computers as systems right from the very beginning. This systems thinking is exactly how engineers came up with the blueprint for pretty much every computer on the planet.
So let's pop the hood and take a look inside. Most computers you and I use today are based on a design called the von Neumann architecture. You can think of it as the classic original blueprint for a computing system.
What's so cool about this architecture is how simple and elegant it is. You've got the CPU, which is basically the brain doing all the thinking. You've got memory, which is where it stores stuff it needs. Then you have your input devices like your mouse and keyboard, and your output devices like your monitor. But the real magic is the communication network that connects them all, something called a bus. Just picture it as the computer's internal superhighway, letting all that information zip between the different parts at incredible speeds.
But hang on, because this is where things get really, really interesting. Systems almost never exist all by themselves. A lot of the time, one system is actually just a tiny part of a much, much bigger system. Let's see how this whole idea scales up.
You can really see the layers here. So you start at the bottom with a physical computer, that's your hardware system. Then running on top of that, you have the operating system, like Windows or Mac OS, which is itself a super complex software system. Then you use a network, another system, to connect your computer to others. And what happens when you connect millions and millions of these little networks together? You get the internet. It's like stacking building blocks, where each block is its own system, creating something way more powerful. At the end of the day, the internet is the ultimate system of systems. And here's the wild part. Nobody's in charge. It's not owned by a single company or country. It's a global network where millions of individual computer systems just agree to connect and talk to each other using a shared set of rules. It's probably the biggest, most complicated artificial system humanity has ever managed to build. So, what's the big takeaway from all this? Well, once you learn to see the world in terms of systems, of components and objectives and connections, you start to see the hidden blueprints of, well, everything. You don't just see a tree anymore, you see an entire ecosystem. You don't just see a company, you see an organizational structure. It's a seriously powerful way to make sense of a very complex world.
And that's where we'll leave it. But I want you to think about this. Now that you have this new lens to look through, what systems are you going to start noticing in your own life? What hidden connections and purposes are you going to uncover in the world around you? Thanks for turning.